Welcome to our DCN video project. We are from Inside More Group. Good morning. Our mission today is to learn about IP for class full addressing, IP for classless addressing, NAT, routing. Before we go to our first mission, let's talk about IP address first. IP address. IP address is known as protocol address. The function to specifies the location of a host or client on the internet. Now, let's discuss about IP for addressing.
Assalamualaikum and very good morning. My name is AZRI and I'm from group of Inside More. Today I'm going to explain about IPv4 address. Let's show you. Okay. IPv4 address. IPv4 address is read as decimal point. The example of IPv4 address is 192.168.17.45. Okay, the way we read it is as 192.168.17.45. That's how we read it. Okay, the minimum of the IPv4 address for each octet is 0. The maximum is 255. This number is based on your class. Okay, now let's go for the number of octet. You see, this one has 1, 2, 3, 4. So it means it has 4 octet. So one IP address is consists of 4 octet. Okay, the way we read it as a computer in binary, we will translate it like this. Follow me. Okay, 192 we divide by 2 to get the binary. The binary number is 1100. 000. For 168 is 10101000. For 17 is 0001001. For 45 is 0010101. Okay. That is all for IPv4 address. IPv4 address is commonly used in our nation because IPv6 technology is still in developing. Okay, now let's roll to the classes and the classroom of IPv4 address.
Definition of IP for classful and classless addressing.
Okay guys, now I'm back with today I'm going to explain about IPv4 address type. Okay, IPv4 address. There are two types of IPv4 address. The first type is class full. The second type is classless. Okay. The class full is about Class A, Class B, Class C, and Class D, and Class E. And 1A, B, C, D, E. Each one of these, there is a range of the IP. There is a range of the IP. Okay, for Class A, we have the range of 1.0.1.0.1 to 126.255 and so on. Okay, for Class B, we start with 128 to 191. For a class C, we are starting from 192 to 223. This one is the most common use in the system for a small business. Okay, the fourth class is from 224 to 239. And the last class is about 240 to 254. Okay. Each one of these has their own function. The first is for a large network. The second is for a medium-sized network. The third is for a small business. The third is for multicasting, and the last is for experiment use. Basically, this one is in lab for just testing the network. Okay. Let's go to the classes. Okay, for the classes, the function is very easy. Let's say the IP that the sender want to send is 192, but in here they have a class. So in here they automatically set the address near the same. It is due to less the waste of the IP. Okay, I think the other part of the explanation or the example will be explained by my friends. Thank you.
Example of if for classful and classless addressing.
Subnetting.
Subnetting is the overall process of dividing an IP network into subdivisions, as can be seen in the diagram drawn. The subdivisions are called subnets. Computers belonging to a subnetwork have a common group of most significant bits in their IP addresses. Essentially, this would break the IP address into two parts. One as the network prefix, 2 the rest field.
Supernetting. Supernetting is called the overall process of combining several subnetworks, as can be seen in the diagram drawn, which have a common classless inter-domain routing, also known as CIDR routing prefix. Subnetting is also called as 1 route aggregation, 2 route summarization. Basically, it is more advanced than subnetting, supernetting.
And now I will be explaining about the difference between subnetting and supernetting.
We'll talk the difference between subnetting and supernetting. And now we begin. In subnetting, the host ID bits for the IP addresses, which is from a single network ID, are borrowed to be used as what the data communication called as the subnet ID, whereas in supernetting the bits from the network identification are borrowed to be used as the host ID. From the explanation, hopefully the viewers will have a better understanding between the subnetting and the supernetting. Thank you.
Explain about the type classful in a network. Connect router to switch. Add one PC to each switch. Now there are 5 types of class in a network. Class A, Class B, Class C, Class D, Class E. What difference them are the range of classes? I am going to explain now about the Class A. Class A ranges from 1.0.0.1 to 126.255.255.254. Now I'm type ... The range is from 128.1.0.191.255.255.255. Next is Class C. The range is from 192.0.1.1 to 223.255.254.254. Next is Class D, that is from 224.0.0.0 to 239.255.255.255. This class is special because it is used for multicast group. Next is Class E, and the range is from 240.0.0.0 to 254.255.255.254. This class is special because this class is used for experimental use. Now I am going to pass the next part to my friend.
Now, let's talk about NAT.
Okay guys, I'm going to talk about NAT. First of all, NAT is a network address translation. And normally NAT is a network device or a firewall which assigns a computer device in a private internet with a private IP in the internet. So NAT have 2 types, and it is a basic NAT and multi-body NAT. NAT is normally used for in the private organization which have many computers, and then they have their own private networks. So NAT is usually most important in the big company and everything for their private information. Right now, I'm going to talk about the other uses of NAT. Normally NAT is used in the network server, which is the private organization or network,
but they also use the web server to improve the network traffic and everything. And then the other thing is NAT improves the network traffic for the engineer to control the network traffic and everything. And then I'm going to talk about the private IP address that NAT normally use, which are the 10 0 0 0 to 10 255 255 555. After this, and then 172 1600 31 255 255, and then 192.168.0.0.168.255.255, and then this is the normal IP address that we use in NAT. And then there's a visit NAT. Visit NAT is a one-to-one translation of the IP address, and then within the visit NAT using the two different network which is incompatible to addressing. After this, I'm going to talk about one-to-many. Okay guys, I'm going to talk about NAT. First of all, NAT is a network address translation, and normally NAT is a network device or a firewall which assigns a computer device in the internet with a private IP in the internet. So NAT have two types, and it is a basic NAT and multi-many NAT. NAT is normally used in the private organization which have many computers, and then they have their own private networks. So NAT is usually most important in the big company and everything for their private information.
Our discussion has come the last part, which is routing.
Assalamualaikum and very good evening. Today I'm going to explain about router. Router is used to connect different networks. Other than that, it is a Microsoft control device that is connected to two or more data lines from different networks. Furthermore, the device that extracts the destination of packet and select the best path for destination and forward packet to the next device on selected path. To explain that, during the data packet travel to the router, it reads the address information in the packet to determine the ultimate destination. Using that information, this routing table will direct the packet to the next network. What is routing? Routing is the process of selecting path in the network along which to send to the network traffic. It is always done on the network portion of destination in IP address. Other than that, indirect forwarding on basis of routing tables which maintain a record of routers to various network destinations. Routing is divided into two parts. One is static and another one is dynamic. Static routing. Static routing uses fixed tables. It also called default routing because there is only one destination network where we want to send a message. Next, I'll explain about dynamic routing. Routers select the best path for the packet or data from routing tables, and also depends upon metric-based calculation and hop count. Routing tables holds the data for making forwarding decision. In order route packet, a router communicates with one another routes using routing protocols and using the information creates and maintain the routing tables. The routing tables store the best routes to certain network destination, the routing metrics, associated with those routes and the path to the next hop routers. That's all. Autonomous system. Autonomous system is a collection of connected internet protocol routing prefix under the control of one or more network operator. Besides, what is address distance? It's measure used by routers to select the best position when there are two or more different routes to the same destination from two different routing protocols. The lower numerical value is preferred. Example, an OSPF route with an administration distance of 110 will be chosen over RIP route with an administration distance of 120. This is the protocol and this is the administrative distance. Firstly, directed connected is 0. Next is static route 1. EIGRP summary route is 5, external BGP is 20, internal EIGRP is 90, IGRP is 100, OSPF is 110, ISF is 115, RIP is 120, EGP is 140, ODR is 170, internal ECGRP is 170, internal BGP is 200, and unknown is 255. Routing protocol. Protocol that specify how to communicate with each other. Next, the routing protocol share this info first among internet neighbors. Now I'm going to explain about distant vector and routing protocols. First, maintain routing stable. Next, update routing info every 30 seconds is commonly used in RIP and IGRP. Now we're going to go to link state routing protocols. In the tables is routing topology and neighboring. It is fast converged and is commonly used in OPSF. RIP is used and resistance is 120 compared to IGRP. The resistance is 100. Next, the max hop count is 15. The metric hop is hop count. The distant vector routing protocols. In IGRP, the max hop count is 255. Distant vector routing protocols are Cisco proprietary protocols. Now we're going to go to BGP, border gateway protocols. Banking the core routing decision internet path vector protocols replacing BGP. EIGRP, Cisco proprietary protocols, hybrid protocol. What is hybrid protocols? Containing functional of both link state and distant vector routing protocol. The metric is dynamic delay. Support IP, IPX, and protocol. Amateur distance, the less 90. Now OSPF. The everything routing protocol, internet protocol network, operate within a single network system. Metric is cost based on BW, cost equals to 100 divided by BW. Link state routing protocol links are deployed in hierarchical design suitable for large network. Amateur distance is 110. Decreased network overhead due to introduction of areas.
IP4 class full addressing. IP4 classless addressing. NAT. Routing. All is done. Thank you for watching our video. This message will not self-destruct due to our zero tolerance policy.